Hello there, my name is Neil Jersenatilis of PSC1, and today we will be solving definite integrals. So I have two challenge problems here. Number one, we have integral of 0 to pi over 8 sine raised to 4 8x cosine raised to 3 4x dx. Now, as we can see from this function here, we can use the was formula, but first we will need to make this 4x. So using trigonometric identities, sine x here is equals to sine 2 times 4x, which is also equals to 2 sine 4x cosine 4x. So this is what we're gonna use. So sine 8x equals to 2 sine 4x cosine 4x. Now if we raise all of this to the power of 4, we will have sine 4 8x. As you can see, it's the same as this one here. So equals to 2 raised to 4 is 16, and then sine raised to 4 4x cosine raised to 4 4x. So we are gonna be using this trigonometric identities. So we'll be using this. Yeah. So now this will become 16. We bring out the constant out first. 16 pi over 8 0 sine raised to 4 4x cosine raised to 4 4x. We copy this here and then copy that also. Cosine 3 4x dx. Now next we will simplify the function. We'll multiply cosine raised to 4 4x and cosine raised to 3 4x. So now it will become 16 pi over 8 0 to pi over 8 sine raised to 4 4x cosine 4 plus 3 is 7 4x dx. Now we will apply u substitution. U is equals to 4x. Its derivative is simply 4 dx. Now if we apply u substitution, we will also apply u substitution on the integrals, the upper limit and the lower limit. So the upper limit first, we have 4 times the x. We substitute the limits to x here. 4 times pi over 8. 4 divided by 8 is pi over 2. And then the lower limit, we have 4 times 0, which is just 0. So next we will substitute it. 16, or rather 16 over, since we have to bring 4 to get du, so 16 over 4 pi over 2 0 sine raised to 4, substitute 4x with u, Assign-7 u and then du. Since 4, we put 4 here, and then we also put 4 next to dx, so we have du, this value here. So next we will apply Wallis formula. So 16 divided by 4 is just 4 times, using Wallis formula, we have 4 here. 4 minus 1 is 3, 4 minus 3 is 1, and then next is 7. 7 minus 1 is 6, and 7 minus 3 is 4, 7 minus 5 is 2, and that's it. And next we will add 4 and 7, that is equals to 11, minus 2 is 9, and then minus 2 again is 7, 5, and so on until you get to 1. And then next we'll multiply it with, since not both of them are even, we'll only multiply it with 1 here. So next cancel out 3 and 3, then we got nothing else to cancel, so I'll multiply 4 times 6 times 4 times 2, 4 times 4 is 16, times 2 is 32, times 6 is 192, all over 11 times 9 times 7 times 5 is 3,465, and this is our final answer. Next, number 2, we have integral of 1 to e dx all over x times ln x times ln x. There. First we will find u. We'll apply u substitution. We will use ln x, and then its derivative is simply 1 over x dx. Next we will substitute the upper and lower limits. Upper limit is ln e equals to, that is equals to 1, and then the lower limit is equals to 0. Now we're going to substitute it. 1 over 0, 0 to 1 du over u ln u. Since dx over x here is simply du, and then ln x is u ln, and then this here is ln x, also u. So next what we're gonna do is we will apply integration by parts to solve this function here. So first we'll find the u, du, v, and the dv. First the u is 1 over u ln u, and then we'll find the derivative of u, that is equals to negative ln u plus 1 all over u squared ln squared u du. Next we get dv from here too, that is just du, and then we'll find the integral of du, which is just u. There. So now we'll apply that integration by parts. So it's a uv minus integral of v du. So it's 1 over u ln u. Wait, let me see. We'll scroll down. 1 over 0 du over u ln u equals to uv, that is what uv is 1 over u ln u, and then v is u here, minus the integral of v du, and v is u and then du first, ln u plus 1 all over u squared ln squared, and then the u du. Don't forget the integral. And next we'll simplify, so cancel out u and u, cancel out u and u here. So what's left is 1 over u ln u minus the integral of negative ln u plus 1 all over u ln squared u du. The integral of 0 to 1. So next we'll find the integral of this part here. To make it fast, it is equals to see. Oh wait, this is not round anymore. Sorry about that. The next it's 1 over ln u minus ln u ln u plus 1 over ln u, and the integral of 0 to 1 here, and then it's we will multiply the negative sign here to both of these terms. That is 1 over ln u plus ln u negative 1 ln u. As you can see, these terms here are both like terms, so we cancel out since this is positive and this is negative. And what remains is ln u, the integral of 0 to 1. So next we'll get the value ln 1 minus ln 0. So from here we can see that ln 0 is cannot be calculated, so this function at the end of it is just undefined. However way you solve it. So that is all. Thank you for watching.